Hi guys, so welcome to another video. The topic for today is sequence and series. Alright, we'll learn this topic in two parts. First, today we will cover generic sequences, which are your basic in general sequences, and then we get into more details of it when we study progression, when we study the concept of AP and GP. Okay. Now, when we talk about generic sequences, right, what are these? See, these are series of numbers, right? For example, say we have 1, then 3, then 6, then 10, 15, and so on, right? Now, if I ask you what is the next term, right? If I ask you what is the next term, right? So, we need to think about it and observe. See, what is happening here? There is a plus 2, then plus 3, plus 4, plus 5. So next will be plus 6, 21, plus 7, which is 28, and so on, right? So the point I'm trying to make is a generic sequence is any sequence of numbers which follow a particular pattern. Okay, now this pattern simply depends on us, like the question maker, right? Whatever they make, whatever pattern or whatever sequence formula they make in the pattern, like the sequence, we simply follow that. We take that as a rule and we simply follow that, right? So for example, if I say the nth term, right, an, right, this is called nth term, right? This, the significance of this n is, this is the term number. Okay, what number of term in your series? All right, so for example, your terms are a1, a2, a3, a4, and so on. So this is the first term, second term, third term, and so on. Okay, now say if I tell you that nth term of a series is given by an minus 1 plus n, right, something like that, and I know a1 is 1, right, a1 is 1. So what has happened? I have given you a formula for the series, right? This is called the formula for the series. Okay, so all the terms in this series will follow this pattern. Okay, will follow this pattern. That does not mean that there is a, n, n and all that. It simply means that they will, each term will follow this pattern. Okay, now first term is 1, that's already given to us. Now if you want to find the second term, right, to find the second term, you simply plug in n as 2. Okay, because we know n, the significance of n is that it tells you the term number. So if I want the second term, I will put n as 2, and a2 is my second term, right, which is, put n as 2 everywhere, we will get a 2 minus 1 plus 2, which is a 1 plus 2, which is 3, because I know a1 is 1. Similarly, if I want to find the third term, put n as 3, a3 minus 1 plus 3, that is a2 plus 3, which is 6, right? So like this, the point we are trying to make or trying to learn is that when you say an, a is just the element of the set. Okay, a just signifies that this is sequence, which is sequence a. N tells you what is the term number. Okay, n tells you what is the term number. In place of a, I can put t, f, g, h, whatever variable I want, or a character also if I want. Okay, this n is important. This tells you the term number, right? And the simple way or the best way to solve any sequence, right, any generic sequence, is plug in values, right? You plug in 2-3 values, try to identify what is the pattern, and then you can simply apply that pattern. Okay, right? Let's take an example. Say, right, I tell you a series an is given by an minus 1, an minus 2, right, plus n. All right, and it is given that a2 is 3, a4 is 5, find a5. Okay, so the moment you see this, you will realize, okay, this does not look like an AP, this does not look like a GP, it doesn't, it just looks like some random sequence, correct? just if I look at it, it looks like a random sequence. So what do I do? Just simple, plug in values. That's the fastest and the easiest way to solve these questions, right? I know A2, I know A4, but I don't know A3. So let's figure out A3. What will I do? I will plug in n as 4. So I get A4 is equal to A4 minus 1 plus A4 minus 2 plus 4. A4 is A3 plus A2 plus 4. A4 is 5, A3, A2 is 3 plus 4. A3 becomes minus 2. Okay. Now that I know A3 is minus 2, the question wants me A5. Question wants the value of A5. So again plug n as 5 now. Right? Now simply plug n as 5. You will get A5 is equal to A5 minus 1 plus A5 minus 2 plus 5. A5 is A4 plus A3 plus 5. A4 is 5. A3 is minus 2 plus 5. Right? We get A5 as 8. Right? The point again, remember, whenever you have a generic sequence, okay, whenever you have a generic sequence, simply plug in values. All right, do not be scared of these random functions, right, and think that, oh, what to do, how to do, right? Don't be confused. It's a very simple logic. Just plug in values. All right, moving on, right, from here itself we will learn that there are various types. Okay, the way you go forward, the same way you can come backward as well, right? Say the same question, right? I have an is equal to an minus 1 plus an minus 2 plus n. Okay, say this is the series. Say I already know a5 is 8, okay, and a4 is 5, okay, and they ask me what is a1, right? So no problem. It's not that in a sequence you only go forward. See, the whole point of sequence is everything follows the same pattern. So if you use the pattern to go forward, you can use the same pattern to trace back, right, or come back, right? So what do we do? I know a5, a4. So the logical thing next is to find a3, right? So what do? I put n as 5, okay, because then this becomes a3, right? I get a5 is equal to a5 minus 1, a5 minus 2 plus 5. 8 is equal to a4 plus a3 plus 5. 8 is 5 plus a3 plus 5. A3 becomes minus 2, which we already know from the previous one. Now I know a3, I want a1. The next step is to logically go and find a2. So again put n as 4. You will get a4 as a3 plus a2 plus 4. Right. 5 is equal to minus 2 plus a2 plus 4. a2 will become 3. Right. And now finally put n as 3. You will get a3 is a2 plus a1 plus 3. Minus 2 is 3 plus a1 plus 3. a1 is minus 8. Right? So the point is that in a generic sequence, do not be scared. They can give us random variables, okay, random sequences, random models, things that look super scary. But you don't be scared, okay? You tell yourself, see, if it is an AP, I know I can use formulas. If it is GP, I know I can use formulas, right? Else, I will simply plug in, right? A1, A2 is given, they are asking A5. Don't directly jump to A5. Think, okay, how do I find A3? How do I find A4? Then I find A5. A5, A4 is given and they ask A1. How do I find A3? Then A2, then A1, right? Just go step by step and simply plug in values and you will be able to solve all generic sequence questions. Okay. Continuing on this, there is one last thing that you should know. There are certain basic sequences whose formulas, if you know, it is better. Okay, if you don't know, you can figure it out in the exam itself, but if you learn them, obviously your calculations will become faster, right? The first such series is sum of n numbers. right? Sum of n numbers, right? This is given by n into n plus 1 by 2. Okay. Now, again, as I said, if you memorize this, great. If you don't, no problem. See, if you look at it, this is AP, right? This is arithmetic progression. Each term is increasing by 1, right? So for AP, what is the sum formula? Right? It is n by 2 first plus last, right? It is n by 2 first plus last. So if you see, it's the same formula. So that is why I said if you learn them, great. If you don't, no problem. You can derive them in the exam itself. Alright. Similar, based on this, sum of odd terms. 1 plus 3 plus 5 plus 7 goes on till 2n minus 1. Okay. Sum of odd terms. That is simply n square. Again, these are n numbers, right? These are n numbers. So n by 2, first plus last. Okay. Last is 2n minus 1. First is 1. When you add 2n, 2 cancels out, n square. Right? So this is, remember, this is sum of first n natural numbers. This is the series for sum of first n odd numbers. Okay. So similarly, if we have even numbers, 2 plus 4 plus 6 till 2n, right? Okay, what do we do? If you take 2 common, right? If you simply take 2 common, doesn't this become 1 plus 2 plus 3 till n? So that is simply 2 times n into n plus 1 by 2, which is essentially n into n plus 1. Okay, which is simply n into n plus 1. Right? Sum of first n natural even numbers. Okay. Apart from this, there are 2 more series that we can learn. That is sum of squares. 1 square plus 2 square plus 3 square till n square. Right? This is n into n plus 1 into 2n plus 1 whole divided by 6. Okay. And cubes. 1 cube plus 2 cube plus 3 cube plus 4 cube till n cube. That is n into n plus 1 by 2 the whole square. Right? Again, if you can memorize these formulas, great, especially these two, right? Even if you don't, in the exam, we will be given the formula, right? We will be given the formula, right? So I hope you understand these basic series. These are, it is expected of us that if we know them, again, as I said, even if you don't know, the first 3 just are APs, okay? You can apply and you can derive the formula then and there itself, all right? Alright guys, moving to the questions. So we have positive integers 1 to 700, sum of all even multiples of 7. Okay, what are multiples of 7? Multiples of 7 are 7, 14, 21, so on. Even multiples means they are even numbers, that is they are multiple of 2 as well. So even multiples will become 14, 28, 42, 56, 42, not 48, right? So on till 700. Okay, and we want sum of all of these, right? Now again, it is up to you. If you observe, this is AP, you can apply AP formula, or else I take 14 common. Okay, 1 plus 2 plus 3 plus 4 goes on till 50. You can either directly apply AP formula and solve, right, or just take 14 common, right? This we know is sum of first 50 natural numbers, that's 50 times 51 by 2, right? That is 50 times 51 by 2, right? You right? So remember one thing, guys, with respect to your calculations, 50 is a very good number, right? Don't disturb that. Okay, 50 is a good number. Try not to disturb that, right? Cancel 2 with the 14, right? That will make your life or calculation faster, right? 7 times 50 into 51 is 2550. This is 17,850. Okay, this is 17,850. Now, as I said, here itself, if you want to apply AP formula, right? So sum of n terms, these are again I know 50 terms. Okay, so that's simply 50 by 2 first plus last. Okay, I simply do 50 by 2 first plus last. 50 by 2 times 714. Okay, 50 by 2 times 714. Again, right? Or let's do one more thing, right? Let's do one more interesting thing. Okay, I can cancel 2 in this, but then multiplying will again be a problem. Instead, because I have a 50, why don't I just make it 100? See, I multiply by 2 and multiply this also by 2, right? What happens? This becomes 100, right? This becomes 100 times 714 by 4, right? Anything into 100 is you just add 00 by 4. Now all I have to do is just divide by 4, right? Just divide by 4. You do that, this is 17,850, right? 17,850, right? Moving on, so we again have a sequence which is already defined by them, right? We know what is T1, they're asking us to find T5. So again, don't be worried, don't be scared. Remember, it's a generic sequence, right? Why is this not, like, why is this a generic and not AP? So see, because it is multiplied by the previous term 3 times, I know it is not AP. See, at the same question come as Tn is equal to Tn minus 1 minus 5. This I say is AP because nth term is equal to previous term minus 5. So whenever there is a fixed addition or subtraction happening, then you say it is AP, right? Here, by looking at it itself, I know this is not an AP, it's a generic sequence. So again, what do? I keep plugging in values. See, I have Tn is equal to 3 times Tn minus 1 minus 5. I know T1 is 4. So what do? Put n equal to 2. Remember, don't be greedy, don't just directly try to put n as 5. It doesn't work like that. Find n2 first, right? So I get T2 is 3 times T2 minus 1 minus 5, right? In the entire question, I have replaced n by 2. I get T2 is 3 times T1 minus 5. T1 I know is 4, so that's 12 minus 5. T2 is 7. Now that I know T2, I will find T3 by putting n as 3. T3 is 3 times T2 minus 5, right? Which is 3 times 7, 21 minus 5, that's 16. T4, 3 times T3 minus 5, 48 minus 5, 43, right? I want T5. T5, 3 times 43 minus 5, 124. Okay. Moving on to the next one. Again, we have a sequence given to us, right? We have a sequence given to us, that is Bn is equal to n square into n minus 1 whole square by 4. Now in terms of n, we need this, right? Now there are two ways to solve it. One is your theoretical way, let's do that first, and then I'll teach you a faster way also, right? So I know Bn is n square into n minus 1 whole square by 4, right? Now as I said, this n tells you the term number, correct? The only significance of n here is it tells you the n number, term number, correct? I can put n as 1, 2, 3, 4, whatever I want, right? So similarly, I can also put n as n plus 1. See, if n is 4 or say n is 1, okay, let's look at some random, instead of taking 1, say n is 2, okay, say n is 2. What do? You write b2 is 2 square into 2 minus 1 whole square by 4. You solve it, you get b2 as 1, right? Or else if you put, you get b3 as 3 square into 3 minus 1 whole square by 4. You get b3 as 9. Similarly, what happened? See, in place of this n, you just put 2 everywhere. In place of n, you put 3 everywhere. Similarly, if I want bn plus 1, what will I do? In place of n, I will put n plus 1 everywhere, right? In place of n, right? In place of n, I am just putting n plus 1. I have replaced this n by n plus 1, right? So bn plus 1 becomes n plus 1 whole square into n square by 4, okay? So now I have bn plus 1, I have bn. The question is asking bn plus 1 minus bn, right? Which is n plus 1 the whole square into n square by 4 minus n square. I can take n square by 4 common, right? N plus 1 whole square minus n minus 1 whole square. N plus 1 whole square is, right, n square plus 2n plus 1 minus n square plus 2n minus 1, right? N square cancels, 1 and 1 cancels, right? This is n square by 4 into 4n, 4 cancels, n cube is the answer, okay? 4 and 4 cancels out, n cube is the answer, right? Now this is one way to solve, right? This is obviously the theoretical way, one way to solve. Or as I said in this entire topic, right, you can simply plug in values, right? See, I already know b2 is 1, right? I already know b3 is 9, okay? In this question, right, bn plus 1 minus bn, right, I put n as 2, right? I assume that let n be 2, okay? So what is it that I want? b3 minus b2, right? I want b3 minus b2. b3 is 9, b2 is 1, right? So my answer becomes 8, right? My answer becomes 8. So if n is 2, the answer for this is 8. Now what I do? In all the options, I will substitute n as 2, because for this question I have considered n as 2, right? Because I am plugging in values, right? So now when I put n as 2, this is 4, this can't be it. This is 32, again can't be it. This is 8, right? This is 9, this is 27, right? So when you are plugging in values, remember, you plug in, you solve, you plug the same value in the options as well, and your answer should match your option value, right? Then you know that option is correct. All right. Again we have Bn, again a random looking series, right? We know B1, we know B2, they are asking B100, right? Again, do not be worried, don't think, oh, how will I find B100, B1, B2 is given, B3, B4, B5, if I go one by one, how will I get B100? Remember, there will be a pattern, right? The questions are meant to be solved, right? Under a certain time, right? So, let us write down the formula first. Bn is modulus Bn minus 2 minus modulus Bn minus 1, right? We know B1, B2, right? So let me first find B3, right? I substitute n equal to 3 because as I said, I will try and figure out what is the pattern. B1 is 0, B2 is 4, right? So if I put n as 3, B3 is modulus B3 minus 2 minus B3 minus 1, modulus B1 minus modulus B2, right? Modulus of 0 is 0, 4. So this becomes minus 4. So B3 becomes minus 4. Alright, that's a different value. So let's go ahead. Let n equal to 4. I get B4 as modulus B2 minus modulus, right, modulus B3. Okay. Modulus of B2 is 4. Modulus of B3 is 4 again. 4 minus 4, 0. Right. So I know B4 is 0. Right. Now similarly, if I go n as 5, B5 will be modulus B3 minus B4. B3 I already know, modulus B3 will be 4. B4 is 0. 4 minus 0 is 4. Now do you see a pattern here? Right? What did we do? We plugged in 2, 3 values. Right? We plugged in 2, 3 values and then we try to find the pattern. Right? So if you see, the pattern is the values 0, 4, minus 4 keep repeating. Right? So every third value repeats. Right? I need B100. Right? So again, I simply do 100 by 3 because the pattern repeats after every 3 values. Right? I get quotient as 33, remainder as 1. Right? That means 33 cycles will be over. Right? 33 cycles will be completed. 100th value will come in the first place. See, that is 1, 2, 3, 4, 5, 6, like that, 97, 98, 99. 99 is where the 33rd cycle gets completed, right? So B100 will be B1, right? B100 will be equal to B1, which is 0. Okay. Alright, an interesting question. See, a person decided to distribute chocolates. He gives half of his total stock of chocolates and then 2 extra to the first child. Okay. Then half of the remaining, and it basically continues. The stocks exhausts after he takes care of 4 children. Right. Now the question is, how many stocks of chocolates are there initially? Right. Again, it's a basic word problem. Do not worry. Don't think what will happen. We'll just go step by step. Right. Say, right, originally the person had 8 chocolates with him. Okay. Alright. Now what is he doing? He is giving half and then 2 extra to the first child. Right? He had A. He gave away these many to the first child. So what is left? Right? Some value will come. I'm saying let that be B. Okay, I don't want A and all. Let that be B. Okay, so B chocolates are left. Again, try to identify the pattern. Now what will happen? He has B chocolates. He will give B by 2 plus 2. to the second child. Let's say he is left with C chocolates. C, he will give C by 2 plus 2 to the third child, right? He will be left with D chocolates. D, he will give D by 2 plus 2 to the fourth child, right? And now he will be left with E. But we know his stock exhausts after he takes care of 4 children. So essentially, he doesn't have anything left, right? Essentially, he does not have anything left, right? Again, try not to make a formula or anything. Just simply write down step by step the pattern. Okay, this is for A1, A2, A3, A4. We know after the fourth, it is 0. Now all we do is simply back solve, right? So from here, right, let's simply back solve. So D minus D by 2 minus 2 is 0, right? If I solve that, this 2 goes there, D by 2 is 2, D is 4. So I know D is 4. That means this is 4, right? Now I solve the same way. C minus C by 2 minus 2 is 4. 2 goes there, 6. C becomes 12. C is 12. So B minus B by 2 minus 2 is 12. B becomes 28, right? B is 28. Solve for A minus A by 2 minus 28 to A is 60. So initially he had 60 chocolates, right? The point is, even if there is a complex word problem, okay, do not worry, just write it down. Now, one thing that we usually do is you try to find this in terms of A, and then you continue with that, right? That becomes little clumsy. Okay, so I did not want to write so much. Okay, I'm a lazy person, don't want to write so much, so I just wrote that as B. I said whatever is left, that is B. Same thing happens, whatever is left, that is C, right? And then you simply back solve. Again, a question similar to what we did just now. So see, we have even number term of a sequence is multiplying the preceding term by minus 1. An odd number term is formed by adding 5 to the preceding term. Okay, first term is 5. Okay, let's just write down the sequence formula. So they say if it is even number term, right, then the formula is preceding term into minus 1, right? And if it is an odd number term, then it is preceding term plus 5. Okay, we know, right, let the sequence be A, right? So A1 is 5, right? Now what will be A2? This 2 is an even number, so I have to apply even numbered formula. So A2 will be preceding term. Preceding term is A1 into minus 1. So A2 will become minus 5, right? Now A3. 3 is an odd number. Formula for odd term is preceding term plus 5. That is A2 plus 5. That is 0. Okay. So I have 5, right? Let me just write all of this here. A1 is 5. A2 is minus 5. A3 is 0. I don't see a pattern as of now. Let's continue. A4, right? A4 again even number term, so preceding term into minus 1. A4 is 0. Okay, A4 is 0, right? A5, odd number term, so preceding term plus 5, so that's 5, a5 is 5. Okay, see, now I can sort of see. Let's just find one more value, right, just as a proof, right? A6 will be a5 into minus 1, that's again minus 5, right? A6 is minus 5, right? Now if you see here, first term is 5, then minus 5, then 0, then 0. Again you see 5 minus 5 has started to repeat. That means the values repeat after 4 values, right? The values are repeating after 4 values. Now what do I want? I want the 102nd term. So again what do? I divide 102 by 4. I get 25 as quotient, 2 as remainder. Okay, 25 quotient tells you that there are 25 cycles that will happen. Cycle number 1, 2, 3, like that. 25th cycle will get over here. I have 2 remainder, so I need 2 more values. 101st term, 102nd term. So 102nd term will be A2, which is minus 5. Okay. So do we understand this? Right? Again, remember, whenever there is a generic sequence given, simply plug in. That's the best and the fastest way to solve all the questions. Okay. Hi guys, so I hope you like the way we covered this topic. Remember, this was a concept builder video wherein we covered a simple concept and tried to solve all the questions using that concept. There is an advanced video with more tricks, right, that will come as part of this series. If you have any doubts, you can post them in the comment section and we can make a solution video for that. Also, you can practice free material of the same topic from our website, okay, and take those tests.